Welcome back. Now we'll look at paper 21 again from the IGCSE and O-level syllabus. As with the previous papers I've just uploaded, this is from May-June 2025. And as always with these videos, if the video is too slow, then you can watch it at 1.5 or 2 times the speed. And of course, as well as watching this video, I will recommend checking the mark scheme just to see the full list of acceptable answers. Okay, so question 1 says, take one box to identify the type of test to only check for the largest or smallest acceptable value. So if we say normal, well, normal, I mean, basically that's valid, right? That's something that's within the range. If we say abnormal, well, that's outside of the range, right? If we say extreme, so yeah, okay, right, this here is the one they're looking for then. This will be the biggest and smallest that's acceptable. And then if we say boundary, so here, well, one is going to be abnormal and then one is going to be extreme. So let's say, for example, it's a test, and let's say the lowest value you can score is 0, right? The highest value is going to be 100. So in this case, right, these would be the two extreme values. Of course, 0 is going to be the lower extreme, right? Obviously 100, that's going to be the upper extreme. Now, if we look at boundary, well, these are going to come in pairs. Okay, so when we say boundary, well, we're going to have one abnormal, okay, which is going to be -1, because -1 is basically the closest that's kind of unacceptable, or yeah, the closest abnormal value, right, to the sort of boundary, or yeah, to the extreme value. Right, then if we look at the kind of the upper boundary data, well, obviously 100 is going to be the, well, extreme or normal boundary data. Right, then if we say 101, well, that's going to be the closest abnormal data, right, to that kind of upper extreme. Yeah, so hopefully that makes sense, right? So boundary is going to come in pairs. One is going to be abnormal, one is going to be extreme. Right then, 2 full requirements for validating inputs and 5 types of validation check are given. Right, draw one line to each requirement. Right, not all validation checks will be used. So if we look at the first one, and to be honest, I would say in the exam, probably read through these 5 validation checks first. Right, so you got length check, format check, range check, check digit, and presence check. So the requirement, date of birth must be between, well, 1990 and 1st of Jan 2010. Right, so that's going to be range. Of course, again, we've got, yeah, the lower bound, upper bound. Right then, 2, name has been entered, so checking, well, yeah, did they enter something, did they not enter something? Right, of course, that's going to be presence check, checking it's not empty. Right, password has exactly 12 characters, right, that's going to be a length check. Yeah, the top one. Right, so student ID must contain 2 letters followed by a 4-digit number, right, that's going to be format check. Right, of course, format check, well, I don't know, checking if like something is a valid email, right, checking if it's a valid phone number, obviously here checking if it's a valid student ID. Right, then if we look at check digit, so just the one that's not included, what we can say a check digit then, basically there'll be an algorithm that's performed on the data, and then basically the output of that algorithm will be the check digit. So if we think about ISBN, right, okay, yeah, and of course ISBN, right, that's the book numbers. Let's say you have some book number, I don't know, maybe 4, 7, 5, 8, right, etc. Right, then let's say at the end you're going to have some check digit. Let's say in this particular example, I don't know, maybe it's like 7, for example. So, okay, yeah, in this case, with the ISBN check digit algorithm, I think first, like, either you multiply by 3 or you multiply by 1. So let's go, I don't know, maybe times 1, right, times 3, times 1, times 3, right, it just alternates. So, of course, well, here, right, 4 times 1 is going to be 4. Right, obviously 7 times 3, well, that's what, 21. 5 times 1, 5, right, 8 times 3, that's what, 24. Right, and basically you would add all of these up, right? Of course, there's also going to be more. I think ISBN usually is it ISBN 13, right? 13 digits. When you add all of those up, right, then you would then mod that by 10. So let's say hypothetically, if our answer, and I think actually this is what we need to add to it. Okay, so let's say hypothetically our answer is 123. Well, then if we mod that by 10, right, modding that by 10 is just going to give us 3. Because we say, yeah, okay, right, so if we do 120 divided by 10, well, it's going to be 12, yeah, okay, 12 remainder 3, right? And then the check digit, that's basically what do we need to add to this, right? So what do we need to add to the 3 in order to make it a multiple of 10, right? So, of course, well, 3 plus 7, right, that's going to be a multiple of 10. Yeah, so in that case, our check digit is going to be 7. Now, actually, for IG, you don't have to know specific check digit algorithms, but you just have to know the general idea that basically there's going to be some algorithm. Of course, yeah, you use that algorithm on the input data that you're, well, sort of checking, validating. And then, of course, yeah, okay, yeah, I guess really verifying, right, not validating. And then, yeah, once it's verified, well, yeah, okay, sorry, right, so if it's verified, the check digit will be equal, right, to the check digit that you expect. Right, so then B, we want to identify and describe one verification check that could be applied when a new password is input into a system. Okay, so I guess for passwords, right, really there's two verification checks when you're talking about inputting data. Right, one is going to be a visual check where you basically just look at it twice. Alright, so what you do is, well, you would type in the password, right, then you'd go through character by character, just kind of making sure you've, input it correct, or input it correctly. And I guess you could also have the password, right, yeah, okay. Alright, so if it's a password, you probably wouldn't write it on paper as well. But let's say, I don't know, you're inputting a passport number. Well, of course, what you would do is you would have the passport in your hand, right? You would then go through, obviously number by number, right? Just checking that you've entered it exactly correctly. And you could also have someone else check it as well, which can also kind of improve the accuracy, right? Because I guess if you check it yourself, well, maybe you might make the same mistake twice. Whereas if you have someone else check it, I mean, they're less likely to make the exact same mistake as you. Alright, however, I think in this case, really a visual check is probably not really appropriate because your password usually is going to be hidden, right? When you type it in, of course, it's just kind of what asterisk out or starred out. So I think a better one in this case is going to be the double entry check. So yeah, let's just write this here. Right, and I think I'm just going to type it. So a description for double entry check, basically you type it in twice and then the computer or the system is going to check that the values that you entered just match. So let's say that, right, let's say the user will enter their password twice, right, and the system will check to make to make sure the passwords match. Right, let's say if they do, right, then I guess the password is accepted. Right, let's say if not, the user is prompted to re-enter their password again. I mean, hopefully that should be enough right, to get the 2 marks there for the description, and of course, 1 mark for the actual name. Right, so then 3, the following pseudocode algorithm uses a count-controlled loop to read in 10 names and store them in the array names. Right, so obviously for count 1 to 10, right, just a simple for loop. Right, then the output, please enter a name, right, input name, and then while they okay, right, so then actually they take that name string and then they just kind of input that into the array index. To be honest, you could actually do that without inputting into the temporary string variable there. Right, then, well, of course, just next count. Right, so we want to rewrite the algorithm in pseudocode using a condition-controlled loop instead of a count-controlled loop. So I think what I'm going to do, I'm just going to open up the pseudocode app and then I'm just going to write it in there and we can, of course, test it. Okay, so I've gone ahead and just declared the variables we need, right, same as the question. I've also copied the code they had just so we can, copy the same messages, etc. Right, copy the same format. So I think first, well, let's just go and do it using a while loop, and I think then I'll just demonstrate using a repeat until loop as well. So let's go here, and in fact, sorry, not for. Right, okay, let's go count, and I think first we just want to initialize that to 0. Right, then we're going to loop, so let's go while count is less than 10, and let's just go do. Because I think what we can do is, well, first we can actually increment count, because we need to increment count so that we kind of insert or assign to position 1. Of course, we can't assign to position 0 or index 0 since there is no index 0 in the array. So let's just go and let's go and increment that first. So if we just go count, and that's going to be equal to count plus 1. Right here, then I think this is where we can just have the message. So please enter a name. Right now, so here we could actually just directly input, so we could go names count. However, I guess if we keep it the same style as this, because maybe they actually give you a mark for inputting separately. Alright, so I think what we can do, let's go input and we'll input that into name. And then what we can do is now we'll just assign this name. So we'll assign the name to the current count, or the names array at the current count index. Then I think if we go end while, and that should work. I think what I'm going to do, let's just go ahead and just loop out. So I think here we can just go count, just sort of reuse that. Let's go 1 to 10. And in fact, I think what I might do, I might make this just 3, just so it's easier to test. Although of course the logic is still going to be the same. Right, then if we just go names, and then let's just go count. Right, then let's go next count. And hopefully this will work. So let's go, A, let's go B and C. Yeah, okay, right, so here we just get ABC, right, that seems to be working. Right, I think then let's try doing it using a repeat until. Yeah, since they said what, use a conditional loop, right, therefore we can either use a while or we can use a repeat until. So let's just go here, repeat, and the condition, right, let's go until. And I guess what we want to go until the count is equal to 3. Yeah, and that should be fine. So let's just test that again. Let's go ABC again. Yeah, and again we get ABC. Alright, so hopefully that's not too difficult. Right then, number 4, a telephone number with 13 characters is input. The first character is a plus followed by a two-digit country code. Right, so for example, what, plus 20, and then I guess what, is that going to be like 10, yeah, I guess 10 numbers. Right, so yeah, 20 is the country code, right, X is the digit between 0 and 9 inclusive. The algorithm checks for the country codes, right, 44 for the UK and 20 for Egypt. Right, we want to write an algorithm to input the telephone number, extract the two-digit country code, right, then output the matching country, and output unknown if there's no matching country. Okay, so I think, yeah, let me just copy all of this, and again, let's just go and run it in the site. Yeah, I'll just delete all of that. Right, okay, so yeah, right, now actually in the exam, I mean, well, okay, yeah, so sometimes they do want you to declare, sometimes they don't. I mean, I would say if they don't tell you, then it's probably best to declare, right, because yeah, maybe they will give you some marks for it. So right, what do we need to declare? I guess, well, we need telephone number, right, now, yeah, okay, what we have to think, right, this is going to be a string, and the reason it's a string is, well, because we have this plus character, right, that's why we can't declare it as an integer. And often telephone numbers, yeah, okay, right, so often telephone numbers, I don't know, maybe you have some, I don't know, like +1, and then, I don't know, let's say like 2, 3, 4, right there, then you have some, you know, hyphen character, yeah, okay, yeah, so, alright, so maybe you also have some space, some brackets, alright, so that's kind of a common mistake that I see people doing, where they will declare a telephone number as being an integer, right, but if you actually look at the characters, of course, right, it's going to have to be a string. Right, so what else do we need? Right, I guess we also need country code if we look at this. Right, and I suppose actually a country code, well, that's also going to be a string, so let's just go there, country code. Right, is there anything else we need? Yeah, I think we don't actually need anything else. Alright, so what we need to do, well, first we need to input the telephone number, so let's just have an output telling them that. And then let's say, please enter, yeah, your telephone number. Right, then we can just input that into telephone. Right, then we want to extract the two-digit country code. So, right, we can go country code, and in fact, am I on the right syllabus? Yeah, okay, right, so I'm on the IG syllabus, right, sort of looking here. Right, okay, so in IG, right, that's going to be substring. And what we want to do, we want to start from the second character, okay, because, yeah, okay, so, if we look, the first character, of course, is the plus, right, okay, therefore, we want to start on the second character, and then we want to get 2 characters. So looking at this, right, the first parameter is the string, so the string we're extracting from is going to be telephone. Right, then x, right, the starting position of the substring, well, that's going to be 2. Right, and then the length of the substring, right, that's also going to be 2. Right, then we want to, yeah, output the matching country, I guess, if it does exist. So we could do this using, I guess, what, an if statement, and then inside the else we have another if statement. Alright, I think here we can also just do it using a case as well. So, right, let's go case of country code. Yeah, okay, right, and then I guess here, so the first one is going to be 44. Alright, so if we find 44, well, let's just output UK. If we get, is it 20? Yeah, alright, and 20, right, then let's just go output Egypt. Right, okay, yeah, and then here, so, okay, this will be the otherwise, right, so if it's not either of them. Right, then, well, here we just want to output unknown. Yeah, and that should be fine, I think. Right, let's go end case, and then let's just try and run this. Okay, and yeah, let's go, I don't know, like plus 44, then let's have a load of ones. Alright, so here we're actually not checking the length, so it doesn't really matter. Okay, yeah, that says UK. Right, let's go plus, let's go 20, and then yeah, let's have a load of ones. Alright, yeah, that says Egypt. Let's go plus, I don't know, 1, 2, 3. Yeah, something like that. Right, okay, yeah, and then, right, so here it just says unknown. Alright, that's working quite well. Alright, now, of course, we could also do that using some if statements if we want. So I guess an if statement, we would have to go like this. Let's go if country code is equal to 44. Right, then we're going to have a then. Right, okay, yes, so then we would output the UK. Right, then we would need an else. And then inside the else, okay, yeah, okay, so this is going to be a nested if. Right, we're then going to get if country code is equal to 20. And again, yeah, then we're just going to want a then, right? So then we output Egypt, right? And then here we just have an else. And then, yeah, I guess here we're going to need a couple of end ifs. So let's go end if there and end if there. Alright, so this here should do the same. I mean, let's run it just one time. Right, let's go Egypt. We'll try this. And yeah, okay, well, that says Egypt. Alright, and I think for these other two situations, that should also work. Right, then B, we want to explain how we could change the algorithm to repeatedly prompt the telephone number until the number entered is 13 characters in length. Right, any code used must be fully explained. Right, so I guess we can say what we can put the input inside a loop, well, inside a conditional loop. Yeah, so I guess either a while loop or repeat until. And basically we would just keep looping. I guess what, yeah, okay, right, so if we're using a while, well, we would loop while the length of the telephone number is not equal to 13. If we're using a repeat until, well, we would, yeah, okay, right, okay, so we would loop until it is equal to 13. Yeah, so I think, right, I think maybe I'm just going to go for repeat until. Right, let's say, yeah, use a repeat until loop. Right, and what, put the, let's say put the input statement inside. Right, let's say maybe we can have an if statement, right, so just checking if it's not equal to 13. And then I guess we can have an error message. Right, let's say maybe, yeah, have an if statement. Right, checking if the telephone number, right, yeah, telephone number, right, okay, yeah, the telephone number length, right, is, okay, right, let's go, yeah, is not equal to 13. Right, let's say, yeah, if not, then output an error message to the user. Right, output an error message to the user, and yeah, notifying them that they should enter 13 characters. Right, okay, then we can say what, keep looping until the length is equal to 13. Yeah, so I don't know, let's say I have this code, or yeah, okay, alright, so let's say have this input, right, let's say have this input and if statement. Alright, yeah, and I think actually we've kind of said this, right? So have this input and if statement inside the repeat until. Right, the repeat until loop. Right, and let's say, yeah, and loop until the length of the, well, phone number, right, is 13 characters. Yeah, that should be okay. Right, now I think, again, let's just go and do this quickly. Now, of course, yeah, okay, right, of course, in this question we actually don't have to write the code, but let's just demonstrate how we can do that. Okay, yeah, so actually in some ways it might be better to do it with a while loop, because, yeah, okay, right, so with a while loop we can just do it, okay, yeah, sorry, so with a while loop we can just ask them one time, and then we can check if it is not equal to 13. Alright, and then I guess if it is equal to 13, well, it will never actually go inside the while loop. So yeah, I think first let's just do it with a while loop just to demonstrate that. So let's see, right, while the length of telephone, right, while the length of telephone is not equal to 13, right, then say output, I don't know, yeah, error, right, well, phone number should be 13 characters. Yeah, characters, right, let's say try again. Right, okay, then we're just going to input the telephone number again, and let's go end while. Yeah, that should be fine. Alright, and then to be honest, like, yeah, okay, so, yeah, okay, alright. Yeah, so I guess actually we can sort of keep that if we want. Right, so the difficult thing is actually entering 13 characters. Right, so that's going to be, yeah, that's going to be 3, and then let's go maybe 10 of these. Alright, okay, so I think that's going to be 13. Yeah, okay, right, that seems to work. Right, let's say now if we just remove one of them, right, that should be 12. Yeah, okay, error should be 13 characters. Let's try now like 14. Again, yeah, error, right, so try again. Yeah, I think that's fine. Right, then let's actually try just with the repeat until. Right, so if we go repeat until, and in fact, let me just paste the phone number there just so I can copy it again. Right, okay, yeah, now in this case, yeah, okay, so here, because we're kind of repeating, yeah, okay, right, so here we're going to do this kind of while it's false. Alright, so because of that we need to switch the logic. Alright, so here we want to repeat until the length is equal to 13. Whereas, yeah, when we're using a while, well, while of course we're checking it's not equal. Yeah, hope that makes sense. Right, okay, yeah, but the thing is here that we can't really do this repeat until like this. Okay, because even here, if we enter a valid number of 13 characters, well, then it's still going to do this at least one time. That's the difference between a repeat until and while loop, or a preconditional, post-conditional. That a preconditional, well, possibly will never execute if the first condition is not true. Right, whereas a post-conditional, well, this will always execute at least one time. Right, so that's why I'm saying here we would need to put this code inside here. Right, and then inside here, then we would need the extra if statement. So then we go if, right, the length of telephone, right, is not equal to 13. Right, then we would have that. And then, yeah, let's just go end if like this. Alright, and again, let's just test this, see if it works. Okay, so yeah, okay, if we enter first time, right, yeah, then that just works first time. If, for example, we make that 12, right, yeah, so error, try again. And then, alright, let's say on the second time, and yeah, okay, there we go, right, so second time it's working. Then question 5 says 2 library routines are used in programming are, well, mod and div. We want to state the purpose of each of these library routines and give one example pseudocode statements for each of these library routines. Right, okay, so, I mean, hopefully people know what these are, right? If you don't, I think the easiest, yeah, okay, right, the easiest example I can think of is if you think about pizza. Right, now if we say mod, this is basically checking the remainder, right? So how many things are left over, right, once we've done the division. Whereas if we say div, well, this is checking how many times can we wholly divide that number by. Alright, so if we think about pizza, now let's say we've got, I don't know, 14 slices of pizza, and we've got 5 people. Now if we do div, right, well, 40, yeah, okay, so 14 div 5, right, that's basically going to be 2, because, yeah, right, okay, so we can wholly divide 14 by 2. Okay, sorry, no, okay, right, we can wholly divide 14 by 5 2 times, right, so in other words, each person will get 2 whole slices of pizza. Then if we say mod, right, so 14 mod 5, well, that's saying how many slices of pizza are left over, you know, once we've given them their 2 slices each, right, so 14 mod 5, that's going to be, well, 4, right, because of course, yeah, 10 slices of pizza were given out, right, therefore 4 slices are going to be remaining. So yeah, let's say that, right, the mod purpose, maybe it's, I don't know, yeah, to calculate the remainder. Right, let's say when, yeah, dividing one number by another. Right, then to give an example, right, so for IG it's going to be a function, so let's go, yeah, okay, let's go here, right, let's go, I don't know, mod 14.5, right, and I guess if we want, we could say that's going to be equal to 4, yeah, although we don't really need to say what it does equal. Right, so div, I guess, let's say, yeah, okay, right, let's keep a sort of consistent format. So maybe to calculate, let's say how many times, let's say one number can be, I guess, yeah, wholly divided, right, by, I guess, yeah, by another number. Right, so let's say here again, let's go div, and we'll go 14.5, right, and that's going to be equal to 2. Alright, so hopefully that makes sense, yeah, how we get those answers. Okay, right then, here's 6. An algorithm has been written in pseudocode to generate a random integer between 1 and 100 inclusive and store the value in n. The user enters a guess for the number and the algorithm indicates whether the guess is higher or lower than the random number. The algorithm outputs the number of guesses when the user has correctly guessed the random number. Okay, so just the simple number guessing game. Yeah, I think lots of people have probably coded this, right? It's a common practice that people do. Right, so A, we want to identify the line numbers of the 4 errors in the pseudocode and suggest a correction for each error. Alright, so yeah, let's try and get these errors first. Yeah, right, okay, yeah. And one thing I'll say is that often I see some people, they sort of find the first error and then here, you know, they just start writing it. Right, then they sort of see the second error, then they start writing it. Right, but the problem with that, well, maybe they go through and, you know, somehow they found 5 errors. Alright, so I think sometimes, you know, people can find something which they think is an error, but maybe it's not an error. Or likewise, you know, people think something is okay, right, but actually it turns out that is an error. So what I would say is try to actually look through the whole code first, right, try to find the 4 errors, right, then once you're confident you've got the right errors, well, then you can actually write them down. Yeah, otherwise you might, you know, write down the wrong ones by mistake or you might miss an error. Right, okay, so first of all, counter is assigned 0. I mean, that seems okay. Right, then n, yeah, we see here, right, so yeah, n is going to store the random number to guess. Right, so here they're going to round. Right, they take random, so random is going to generate a real number in the range from 0 to 1. Right, then they multiply that by 99. Yeah, that seems okay. Right, here this seems a bit weird. They're rounding it to one decimal place. Right, but if we look at this, we actually want to generate an integer. Okay, so I think this is going to be our first error. Alright, and then yeah, so if we look, like, is this actually going to generate a number between, well, what, 1 and 100? So if we look at this, well, random times 99, right, therefore that's going to generate a number from, well, 0 to 99. Right, then if we plus 1 to it, well, of course, right, then that's going to go from 1 to 100. Yes, so I think actually the random is actually generating the correct number, or yeah, the sort of correct range. Right, then if we go repeat, so output please enter a guess, that seems okay. Right, input G. Yeah, I guess what G is guess. I mean, yeah, here they don't tell us the name of that, but I mean, it seems okay since they're using it here again. Right, so yeah, if G is greater than N, right, then we output the number is lower than your guess. Yeah, okay, and I think this is work. Yeah, okay, this does work, even though it seems almost like the logic is maybe in reverse. Yeah, but I mean that does work, right? Yeah, okay, right, because here we're saying the guess is bigger than the number, right? Therefore, yeah, the number is lower than the guess. Right, that does make sense. Right, then the next one, so yeah, else, right, if G is less than N, right, the number is lower than your guess. Okay, so right, yeah, okay, so of course here this is wrong, right, because both of these say lower. Alright, so I guess this one here should say higher, right, that's going to be our error 2. Right, then we go counter is counter plus 1. Right, now this seems okay, but we actually want to look where they've put this. To be honest, it's kind of weird what they've done with indentation. Really, this else, right, this should actually be indented, you know, in line with this if statement. So what they're saying is, well, if G is greater than N, right, then obviously they output this, right, else, so well, else if it's not greater, you know, or if they're equal, right, then I guess it's going to do all of this code. Alright, yeah, so okay, so what we can say is actually, if, for example, yeah, okay, right, so if we get this is true, right, so if G is bigger than N, well, then it's not going to increment the counter. So what we actually want to do, we actually want to put this counter after the end if. Yeah, okay, right, so otherwise it's not going to increment every time. Hopefully that makes sense. Right, and then, yeah, so here then we're going to loop until G is equal to N. I mean, that makes sense because I guess, well, that's when they guessed it correct. Right, then output, so well done, you took, and then, well, guess attempts. Now, I think guess they actually haven't declared anywhere. Yeah, that just doesn't even exist. Alright, and I think actually this should be counter. Alright, so yeah, okay, yeah, so counter is actually, well, the number of guesses they've had. Yeah, so that seems to be the 4 errors. Now, I think I'm just going to zoom out and then probably let's just type it. Right, so the first error, that's going to be what on line 2. Right, then the correction. Okay, so basically we just want to have 0, right, rather than 1 as the parameter, yeah, for the round. So let's go N, and we're going to assign that round, right, then it's going to be random. Then again, we still want to multiply by 99, right, okay, but here the second parameter is going to be 0, and then, yeah, we're still going to keep the plus 1. Right, then if we look at error 2, so I think that's on line, yeah, that's on line 12, right? Yeah, okay, line 12. Right, the correction, so okay, let's just write this at output. Right, the number is higher than your guess. Yeah, that should be fine. Right, then 3. Right, okay, let's go 14. Right, let's say, yeah, I guess what this line, let's say incrementing the counter. Right, should go, I guess what, after the second end if. Yeah, okay, let's say that, yeah, okay, so should go after the second end if, right, on line 15. Yeah, I think that's fine. Right, then error 4, right, so that's going to be line 17. Right, and then here, well, let's just type this again to output. Yeah, well done, you took, right, then it should be counter, and then, yeah, attempts. Alright, and yeah, I think hopefully that's all correct. Right, then B, we want to identify one method to make the algorithm maintainable, and we want to give an example. Right, so let's see if we can get all of these. When they're talking about, I don't know, making the code clear, making it maintainable, organised, I guess what one we can say comments. So let's say add comments to explain what the code is doing. Right, okay, and then okay, let's say why this is useful. So I guess what is useful to yourself in future, right, or other programmers working on this code. Right, let's say that let's say this is useful for both yourself in future. Right, let's say when you may have forgotten what the code does / how it works. Right, let's say and for other other programmers or developers who might look at right, or work on your code. I think that's fine, right? So probably another one you could say, and of course here it does say only one. Right, let's say another one. I don't know. You say what, like meaningful? Say meaningful identifiers. So for example, here they go what G and N. Right, so rather than calling it G, you can probably go what input guess. Likewise N. I mean, I don't know. N can be like what number to guess or target number. So just make the sort of variable names or the identifier names clearer. And I guess you can also have what functions and procedures. So create modules. Now, honestly, I mean, this is only 17 lines. That's probably not too long. You might not have to make that into functions and procedures. I mean, right, like possibly on line 2, if, for example, we commonly have to generate a random number in a range, then maybe you'd want to generate, maybe you'd want to make some function. Let's say the function, it could be called like rand range. And let's say this would go like 1 to 100. Alright, so if we call that would then generate a random integer in that range. Alright, and of course the advantage of this is, let's say we want to change this. Let's say we want to call it, another time, and we want a number between 5 and 10. Well, then of course all we have to do is change the arguments, right? Change the parameter values, and of course that code is then going to give us, or that function is going to return us a value in that range. I think was that. Okay, that's everything, right? Okay, then for 7 says consider the logic expression where x is equal to a and b, right? Then we XOR, and that's going to be b or not c, right? We want to draw a logic circuit for this logic expression, and each logic gate must have a maximum of 2 inputs, right? And do not simplify the logic expression. Okay, so since this XOR is in the middle, of course that's going to be at the end. Since it's kind of not inside the brackets, right? So I think I'm just going to start here left to right. This is inside the brackets. So of course we're a and b. Let's just join those up. Of course, the and, it's just this D shape. Right, okay, then we want B or not C. So I think maybe first, let's just do the not C. Right, okay, then we want to OR that with B. So of course, OR that, that's going to be this one, this kind of pointy one. Right, and then finally, then we just want to XOR these two together. Right, so of course, XOR, that's going to be the extra line. Then just this OR gate like that. Probably again, like not the best diagram. Alright, and right. So what I do recommend is, if it's not obvious which logic gates you've done, right, then you can just write them here. Okay, so to say, right, that's going to be an and, that's going to be an or, right, that's an XOR, and I guess that's obviously going to be a not. Although I think the not is fairly obvious. Right, okay, then it says complete the truth table for the given logic expression. Alright, so can we? Right. So let's just try and write this again. Right, so the first kind of sub-expression we need to evaluate, I guess. Let's go what a. Right, hang on. Let's just erase that. So I guess a and b. Right, so a and b. Right, then the next one, I guess let's go not c. Right, then I guess b or not c. Alright, and then I guess finally then we just XOR them together. Alright, so that's going to be the X. Okay, so let's go and do this, right? So the first one, A and B, and what I'm going to do, I'm just going to look for where they're both true, of course, here and here. So let's just write 1 and 1, and then of course everything else is just going to be zeros. Right, then if we look at the next one, not C, so here it just alternates, right? So 0, 1, 0, 1, 0, okay. So then of course we just go 1, 0, 1, 0, just alternate these like this. That should be fine. Right. So then we want to go B or not C. So I guess here, of course, right, right, so here we're just looking at this column. So here we've got 0 or 1, right, therefore that's going to be 1. Then 0 or 0 is 0, 1 or 1 is 1. I guess 1 or 0 is 1. right, 0 or 1, that's going to be 1, 0 or 0, 0, yeah, 1 or 1, and then right, 1 or 0, yeah, that's mostly 1s. Right, and then I guess we just XOR, so we're XORing this one and we're XORing this one. Alright, so with XOR, if they're different, it's going to be a 1. If they're the same, it's going to be a 0. So here, well, 0 XOR 1, alright, they're different, therefore it's a 1. Right, then we've got, well, 0 XOR 0, it's the same. Right, then, well, 0 XOR 1, 0 XOR 1, yeah, 0 XOR 1. Right, okay, then it's, well, 0, 0, 1, 1, okay, sorry, yeah, 1, 1, and, yeah, 1 XOR 1, like that. Alright, and, yeah, I think that should be fine. Right, now, yeah, okay, so I will say, if you want to practice these, I do also have a website for this, I think, well, booleanlogic.pro. So let me just try and copy this. In fact, right, yeah, not including the minus, sorry, yeah, okay, not including the equals. Yeah, it's not, okay, there we go. Right, and then if I just kind of minimize that. Alright, okay, yeah, alright, so, actually I've pasted that already, I guess. Alright, so if we just paste that in, well, here you can actually see it's generated the logic circuit. To be honest, like, the logic circuit is not laid out the best. You know, I can probably fix this at some point. Yeah, try and make it a bit more compact. Alright, but if we do actually look here at the truth table, right, then we do see the truth table has successfully generated. Alright, and we can see, yeah, that's actually going to be the same as our answer here, right? So 1, 0, yeah, then 3 1s, yeah, which we see is the same here. Alright, we can see here it's also generated the sum of products. So the sum of products, basically that's where it says, yeah, right, okay. Alright, so with these sum of products, that's when, let's say they give you the truth table, for example, just this final row, and they say write an expression for this truth table. So what you want to look at is you want to look here, right, yeah, okay, sorry. So we look when the output is 1, so of course, well, here the output is 1, and can I sort of zoom in on that? Right here, yeah, obviously here the output is 1, here the output is 1, here the output is 1. So what we do is we say, well, the outputs are 1 when, well, A is equal to 0, B is equal to 0, and C is equal to 0. Of course, right, this first row. So what we say, well, that's not A, and not B, and not C, right? Okay, then we OR it together, and we say, well, yeah, OR this condition, right? So this condition, well, this is when, well, A is true, right? So yeah, okay, sorry, okay, no, okay, so not A, yeah, so not A, right, and B, and not C. Right, then if we look at this one, so here, well, that's going to be what, not A, yeah, and B and C. Obviously the next one, well, this is A, right, and not B and C. Sorry, yeah, okay, and not B and not C. Right, and if we look at that, then yeah, that should be here, right? So not A and not B and not C, right? That's of course 0, 0, 0. Obviously this, right, or, well, not A and B and not C. So well, that's going to be 0, well, 0, 1, 0, which is, I guess, yeah, this one here, right, 0, 1, 0. Then obviously, yeah, just etc. here. Yeah, okay, yeah, yeah, just giving us those 4, yeah, those like 4 conditions. Alright, yes, so the benefit of this site is, of course, well, you know, you can just sort of type, and kind of as you're typing, well, then it's just going to generate the logic circuit, yeah, generate the truth tables right as you're typing. And to be honest, actually, I do want to add a lot of stuff to this site. For example, things to, well, automatically simplify the expressions. Yeah, also some kind of A2 stuff as well. But yeah, I guess, you know, this is IG. So to be honest, actually for IG, I mean, this actually has everything you need, right? Just, yeah, obviously, well, kind of outputting the logic circuit, obviously, yeah, creating the truth table, yeah, and also, well, you know, creating or outputting these sum of products, all right? So that's really going to be the 3 things you need for IG. All right, then I guess databases. So a bus company has set up a new database table called bus to store details of the buses leaving the main bus terminal, right? So that's got a route ID, right, obviously the primary key. Right, so destination, I guess, well, some string, right, varchar. Stops, right, integer. Driver, again, well, string, varchar. Yeah, although to be honest, I guess actually when we're talking about databases, they don't call it strings. Yeah, I guess, well, sort of text is what they call it for Cambridge. I mean, in reality, you'd probably say varchar for these. Right, and then time, I guess, well, that's just like the time, right? There's also date, there's time, yeah, there's date time, which is, well, the combination of date and time. Then, well, return, so just a Boolean. And for, yeah, okay, so for some reason Cambridge say yes and no. I mean, in reality, of course, Boolean is going to be true and false. So yeah, I'm not sure why they say yes and no for these. Right, then we want to identify one appropriate data type for the field return. Right, okay, so return, right, yeah, so that's going to be the Boolean, which we just said. So let's just go Boolean. Right, then state the reason for the data type chosen. So I guess what, since it only contains, well, yes or no. Right, since the values are only, well, yes, and I'm going to put in brackets true, right, or no. which of course is going to be false. Right, then we want to write the output from the structured query language or SQL statement. Right, we're selecting, I guess, three things, right? The route, the destination, and time. Obviously from the bus table, where the driver is A. Patel. Alright, so I'm just going to zoom out just so we can see all of it on one page. Alright, and I think what I might do is let's just find all of these rows then. Right, so where the driver is A. Patel, well that's going to be this one, it's going to be this one, and it's going to be this one. Yeah, I think just those three. Right, and then yeah, we want to select the three things. In fact, let's just sort of zoom out a bit more. Right, so let's try and write this then. So first we want the route ID, so that's going to be what, BC02. Then the destination, so right, the fountain. Right, and then we also want the time, so yeah, I guess let's just go 9:10 like that. Right, then the next one, so that's going to be right, BC08. Yeah, I mean hopefully this is fairly easy, right? It's just kind of making sure you copy it down correctly. Right, so sunset key and right, 12:01. Yeah, I think I copied that correctly. Right, then the next one, so BC27. Right, that's going to be the university. Right, and then the time, right, so 16:45. Yeah, that should be okay. Right, so then we want to complete the SQL statement to display only the destination of the buses that have a return. Right, so of course here then we're looking, well, where return equals true. So where return equals yes. Right, so yeah, what we want, right here then we want to select the destination. Right, and then we're going to say from. So from, right, the table name is bus, and then we just want the where condition, right, just filtering. And we want to go what, and in fact, is return capital? Yeah, okay, right, so return's a capital letter. Right, okay, so where return equals, and let's just go yes. Right, and because it's a Boolean, then, I mean, we don't really need to put yes in quotes. Okay, right, so, so a Boolean is not, right, it's not going to be a string, right, it's not inside quotes. Right, okay, then 9, so the variables A and B are used in the program. A holds a whole number and B holds text, and we want to write pseudocode statements to declare the variables A and B. Alright, so that's not too difficult, hopefully. So let's go declare, and right, we say A, right, okay, so A holds a whole number, right, therefore it's going to be an integer. Right, then we go B, so declare B, and right, that's going to hold text, so right, that's just going to be a string. Right, okay, then it says the function odds x, so I guess that's the parameter, returns odd, well, the string odd if the value of x is an odd number, and returns the string even if the value of x is an even number. Right, we want to write pseudocode statements to define the function and call the function using parameters A, right, and return, and yes, okay, store the return item in variable B. Okay, so I think what I'm going to do, let's just copy this code, and then I think, yeah, let's just go ahead here and we'll just write that. Alright, and in fact, yeah, let me just copy the instructions. Okay, yeah, hang on, right, let's close that. Right, okay, right, so here then the function is called odds, so let's just go function, or well, I guess, yeah, odds. Right, here then it's going to take a parameter, let's just call that n, right, and that's going to be an integer. Yeah, I mean, I think it, yeah, okay, right, integer, right, since what A here is an integer. Right, let's go returns, and here then, well, it's going to return a string. Yeah, because we see it's going to return either odd, yeah, or even, right, the string. Okay, so the way we check if something is odd or even, well, we're just going to use mod 2. So let's go if, and let's go mod, right, the number we're modding is going to be n, and we're checking, yeah, if we can mod that by 2. Right, so if equals 0, well, then it's going to be even. Okay, because for example, yeah, okay, for example, if we do 2 mod 2, right, that's going to be 0. Again, 4 mod 2 is 0, you know, 6 mod 2 is 0, etc. Yeah, okay, right, so if we mod, okay, sorry, so if we mod an odd number, right, let's say, for example, 1 mod 2, well, that's going to be 1, right, 3 mod 2, 5 mod 2, 7 mod 2, right, all of those are going to equal 1. So let's go here, return, and, right, this is going to be even, and, yeah, okay, right, so that, okay, then we can just have an else, right, because there's only 2 conditions. Yeah, either it's going to mod to be 0, or it's going to mod to be 1. Right, then just go return, and then we can just return odd. And yeah, I think then just go end function. Okay, yeah, that should be fine. Right, then it says we want to call the function using parameter A and store the return item in variable B. Alright, so let's just do that. So, right, we want to go B, and then we just want to go odds, and right, the parameter here is going to be A. Yeah, that should be fine. Right, now probably what we, yeah, okay, right, what we do want to do, which, right, okay, so the question didn't actually ask for this. However, if we want to test it, right, of course, we actually want to assign something to A. So let's go, for example, 5. Now, this should return odd. Alright, and again, yeah, okay, right, so the question doesn't ask us to do this, but let's just output B, right, just so we can actually see. Yeah, okay, right, yeah, so here we get odd. Right, then let's just, for example, go 4. And then, yeah, okay, right, so 4 goes even. Alright, and I think this is a new thing on the site. Now, actually, if we don't assign anything to A, right, then it should actually give us an error, yeah, if we try to use A without actually assigning anything. Yeah, okay, right, so no value has been assigned to integer A, right, so just kind of warning us that. And to be honest, if you want, you can turn off that warning here. I guess, yeah, this require initialization. Yeah, just turn that off, kind of if you want to disable those error messages. Right then, if we look at 10, so the flowchart represents an algorithm to calculate grades, and let's just read this first, right, so we start, then we input the score, we check is the score greater than or equal to 40, if it is, we then assign C to grade, right, if it's not, well then we check is score greater than or equal to 60, right, we assign B to grade. Right, now, okay, yeah, actually, maybe you can see an error with this, like, let's say, for example, they score 70, well, 70 is going to be greater than or equal to 40, right, therefore it's going to, well, obviously assign C to grade. However, in reality, of course, well, 70 should be assigned here. Of course, you know, assigning it this B. Alright, so yeah, this is kind of the problem where if we check the smallest one first, well then anything bigger than that smallest sort of condition, right, is automatically going to be true. Alright, so I think therefore what we need to do, we actually need to swap the order of these in order to get the logic working properly. Alright, and I think, yeah, here, yeah, okay, right, so here we see B, right, it basically says, well, yeah, what's the error in this flowchart? So I think we found the error already. Right, anyway, so here what we want to do, we want to complete the trace table for the algorithm using the input data. Right, so let's maybe go ahead and just split screen just so we can do this a bit easier. Okay, so the first one here then said we want to input 21. Right, then if we look at the grade, so if we just go over here to the flowchart, okay, yeah, right, okay, so here we are. Right, so here then, well, 21 is less than 40, right, therefore we're going to go to the no. Right, it's also less than 60, right, therefore no, right, less than 80, right, no. So then we just want to assign D here. Okay, hang on, right, let's... yeah, so where's the mouse gone? Okay, there we go. Right, and then, yeah, I guess if we go back here, right, so that's going to be D. Okay, yeah, that's not too useful. Right, then, I guess if we look at the output, so of course, yeah, we can look here for the output. So, right, let's go, what, yeah, you achieved a, and then, well, yeah, okay, just D, right? Okay, yeah, so just you achieved a D. Right, then if we look at the next one, so then we go 46, and I think we can just do these quite quickly. So of course, well, 46 is greater than 40, right, therefore the grade is going to be a C. Alright, and I guess here it's just going to be the same, right, so you achieved a C. Right, then the next one, so 63, right, that one, okay, so 63, well, again, that's bigger than 40, right, therefore it's going to be a C. And I guess let's just write that again. Right, so yeah, you achieved a C. Right, then the next one, so 91, and again, I mean, that's just going to be a C again, because, yeah, the first condition is always true. Right, yeah, you achieved a C. Right, and then the final one, right, that's going to be 12. And then to be honest, like, we can actually just see this instantly, right? So yeah, okay, this is going to be D because it's going to fail all the conditions. And let's go, yeah, you achieved, right, a D. Yeah, I think that should be fine. Right, let's just zoom in and then we can sort of do the next one. Right, so then B, we want to explain how the flowchart can be changed to produce the correct output. Okay, so this is kind of what we were saying. That I guess what basically we just have to swap these. Okay, where's the pen? There we go. Okay, yeah, so basically we have to swap these two conditions. Alright, so the first one, what this should be 80. I guess, yeah, okay, right, the next one should still be 60. And of course, well, this one here should then be 40. Alright, and I guess likewise, of course, well, that has to become A, right, that's going to stay at B. And yeah, that's going to stay, okay, that's going to go to C. Alright, so I think, well, that's going to be the 4 changes we need to make. and then yeah, here we see, right, 4 marks. So let's try and say that. Let's say, I know, yeah, the order, I know, yeah, the order of grade checks, right, needs to be changed. Right, let's say, yeah, first we should check, right, if their score is greater than or equal to 80. Greater than or equal to 80, right, and assign them, or yeah, okay, right, let's say, yeah, assign their grade, right, assign their grade and A, yeah, if it is. Right, okay, let's say then, right, yeah, well then we keep the B condition the same. Right, let's say, yeah, then keep the greater than or equal to 60 and B condition the same. Right, yeah, and let's say what, and finally we should, I don't know, yeah, make the last condition, or well, make the last if statement. Make the last if statement check if the score is greater than or equal to 40. Unless, yeah, and if it is, right then assign their grade. Yeah, their grade to be a C. Yeah, I think that's all we can write really for that, because there's not really anything else we need to change. Yeah, so hopefully that should be enough there for 4 marks. Okay, so on to question 11, the 50 marker. It says the one-dimensional 1D array competitor name contains the names of 25 competitors in a tournament that includes 5 events. Another two-dimensional 2D array competitor score contains the points scored by each competitor in the 5 events. The first dimension of this array contains the index of the competitor from competitor name, and the second dimension contains their scores. Each competitor receives a score out of 100 for each event, and these scores are manually entered into competitor score. Right, medals are awarded to the competitor or competitors, right, so there could be multiple winners, who have the highest points scored in each of the 5 events, and also who have the highest total points scored for all 5 events. Right, I guess, yeah, their combined scores and individual event scores. Right, the one-dimensional 1D array points stores the total number of points stored for each competitor, or well, scored. Right, write a program that meets the following requirements. It's going to take as input valid scores, right, between 0 and 100 for each competitor in each of the 5 events. It then calculates the highest points scored for each event. It's going to output the names of the competitors who receive a medal for the highest points scored, and it's going to calculate the highest total points scored for the 5 events, and also output the names of the competitors with the highest total points scored for the 5 events. Where it says you must write pseudocode or program code and add comments to explain how your code works, and you do not need to declare any arrays of variables, right, and all inputs and outputs must contain suitable messages. Okay, so what I've gone ahead and done, I've gone ahead and just made some kind of sample data here. Well, yeah, just in right, WPS Excel. Alright, so this is kind of the data, right? So when we say the rows, this is what the competitor ID. So here we see what the 25 competitors. Then if we look at the columns, like let's say for example this one here, well of course, right, this is competitor 5, right, in event 2. Alright, so hopefully this kind of makes sense, the sort of structure of the data, yeah, what we're needing to loop through. Alright, so what I've done, I've gone ahead and just, you know, created this, yeah, kind of like, well, the arrays, right, the sample data as well. So if you actually want to start with this, then what you can do, if you go to exam questions, right, click on questions, and then of course you can see, right, this starter code for, well, all of the questions, yeah, not only this one. Right, then I guess, yeah, if we go opening code editor, and yeah, this might take a little bit of time. Okay, right there, yeah, there we go. So let me just move that across and let's just go full screen. Okay, so yeah, right, so here I've also included this sample data, you know, if you don't want to input, well, obviously, yeah, 25 by, you know, 5 lots of data. However, I'm just going to delete this because, yeah, we don't really need it. And I think I'm also going to paste, yeah, I'm going to paste the instructions there as well. Right, now, yeah, okay, I think what I'm going to do, just to sort of make it easier to test, I mean, as I've seen here, right, rather than making it 25 competitors, let's just go ahead and make it 3 competitors. I think likewise the number of the number of events, let's just make that 3, And since here I've just used these constants, well then that's going to create an array, of obviously 3 competitors, or of 3 strings. So rather than having all of these, well, let's now just go ahead and just make 3 of these. That's going to be our 3 competitors. Right, okay, so let's see what we need to do first. So first we want to take as input valid scores between 0 and 100 for each competitor. Okay, so I guess for that we just need a simple loop. Right, so I think here I will declare, just because on the site I have to. Of course, in the exam you don't have to actually declare this. Let's go, I don't know, maybe like competitor number. Alright, so this is just saying, what's the competitor index? I think, alright, so maybe let's call it index, right, rather than num, because if we call it num, I mean, you might think, well, this is how many total competitors there are. Whereas I guess if we call it index, right, that's kind of less ambiguous. Alright, and I think what I'm going to do, I'm just going to declare variables as I need them. I'm not going to try to think of all of them at the start. Right, so what we can do then, if we just want to input the 5 events, well, we want to loop through all of the 5 events, right, and all of, right, so I guess here we've just made it 3, we made it, 3 events, 3 competitors. So we need to loop through all of the competitors and all of the events. Alright, now, so here we can actually do it in either order. So we can have the competitor loop on the outside, right, so it's the outer loop, then the events on as well as the inner loop. However, so if we actually do it the other way around, then we can actually calculate who got the highest score in that event. Kind of like without needing an extra loop. Alright, so I think what I'm going to do, I'm going to have the event, the sort of competition, right, the event as the outer loop. Right, then I'll loop through all of the competitors. Then I can actually get who scored the highest for that particular event. Without needing an extra loop later. So let's try and do that. I guess competitor index, let's go maybe event index. Right, so here then we want to loop the event index, that's going to start at 1. Right, and let's go to, that's going to be the number of events. Now in the exam, of course, you can hard code that as just 5. Right, however, since I've just made it a constant, well, let's just go num events. Right, then what we want to do, I guess we probably want to declare some variables. So this will be who got the highest score. So in fact, right, let's go, I don't know, like highest score. Alright, and I guess, well, that can be the highest score for this particular event. I think we don't really need to declare, multiple variables for like the highest score for this event and then the highest score overall. We can actually just reuse this same variable as we need it. Right, so I think what we can do first, let's just assign this to 0. Because it is like the start of a new event, right? Therefore, we just assume that's 0. Right, then we want to loop through the competitors. So let's go competitor index, that's going to be 1. And here then we just go to the number of competitors. Right, and I think here we have to validate, so they have to enter a valid score between 0 and 100. So here we can either use a while or we use a repeat until. I think maybe I'm just going to use a while. Alright, so I think first let's just ask them to input their score. So let's say, please enter score 4. Right, then I think I'm going to output the name. So the name is going to be the competitor name. Alright, the particular index is going to be the competitor index. And let's just sort of move that across. Alright, so let's please enter score 4. I don't know, is that like, Confucius? Right, let's say, I don't know, maybe in, event. Let's just have the event index. Right, so that should say please enter score 4, right, the competitor name, right, in event 1, event 2, kind of etc. Just sort of telling them what they need to enter. Right, then let's input that, and we can input that directly into the array, to be honest. The array, that's going to be competitor score. Right, the index is going to be, the competitor index, and then, the event, of course, that's the event index. Right, and then I guess we can then just have a while. Right, so here we just want to check if it's outside of the range. Although to be honest, this is going to be quite long because, we're going to need to write this over and over again. So I think what I might do, let's just insert that into some temporary variable. Let's go temp, and I'll just keep it uppercase, just to keep it consistent. Right, so what we'll do, let's go while temp is what, less than 0, yeah, or temp is greater than 100. Right, then we're just going to say error. Let's say error, right, yeah, okay, right, error score should be between 0 and 100 inclusive. Right, let's say try again. And right, let's just input again. So yeah, input into temp, right, then we can just end while, of course, yeah, once it's a valid score. Right, once it's a valid score, well then I guess we can actually assign it. So let's just paste that. Right, then we're going to assign, yeah, okay, we're going to assign that temporary variable, okay, the thing we input. I think then we also need to add this to the current player's points. Yeah, because it says we have this points array. Where does it say that? Yeah, it's kind of difficult to see here. Okay, right, yeah, so here we go. Right, so the one-dimensional 1D array points stores the total number of points scored for each competitor. Alright, so because this is obviously, well, we're looping through each event, right, therefore we need to actually add this to the points. Right, so points, and then the index is going to be the competitor, well, the competitor index. Alright, yeah, okay, and okay, because we're adding this to like a running total, well, then we just want the same, right, so it's going to be points competitor index, and then, right, plus this temporary variable. Right, and I think now what we can also do is we can also check if this is the high score for this event. So let's go if, and we see, right, if the temporary variable, so that, you know, the thing we just input, right, is greater than the highest score, well then what we want to do, we then want to set the highest score, right, to be equal to the temp variable. And yeah, I think let's just go end if for that. Right, then I think we go what, next competitor index, and I guess, yeah, next event index. I mean, right, is that all we need to do? Alright, and yeah, okay, so I think what we can do actually, after we've input all the competitors, alright, so after we've input, well, in this case, 3 competitors, of course, if it's real, right, it's going to be, what, 25, alright, but once we've input those 3, well, then we can actually output all of the people who got the winning score, alright, because, yeah, okay, so we know the highest score here, so we then just want to loop through all of the competitors and check if their score equals the high score, and if it does, well, then we can output them. So let's go ahead and do that. So let's go for competitor index, that's going to be 1, and again we go to the number of competitors. Right, we want to check, so the way to get their score is going to be competitor score. Right, so the index is going to be competitor, or yeah, competitor index. Right, so here we're still using the event index. Right, because if we look at this, so currently we're on event 1, right, so here we're just looping through all of the event 1 scores, and we're checking that if that's equal to the highest score, well, then we just want to output. Yeah, and alright, okay, I think let's maybe have an output here just to say what this is showing. So let's maybe go, I don't know, event, right, let's say event, right, then we can have the event index, and let's go like winners. Alright, because yeah, okay, right, so maybe there's one winner, right, maybe there's multiple winners, yeah, that got the same score. So here I think we can, okay, yeah, so I think what I'm going to have the name and the score. So right, the name then is going to be the competitor name. Right, here the index against the competitor index, and let's go, I don't know, maybe scored. Right, and then I guess we can really just copy this. And then let's go like points. Yeah, I think that should be okay. And then let's just go end if, and here let's go what, next competitor index. Yeah, just to kind of, you know, close, well, sort of, yeah, like loop through each one, right, iterate through each competitor. Right, okay, so yeah, what have we done? So take as input the valid scores, yeah, we've done that. Right, calculate the highest points for each event, alright, we've done that. Alright, output the name of the competitors who receives the medal for the highest points in yeah, okay, right, for each event, yeah, I guess we've done that. Right, okay, so now we need to do is calculate the highest total points for the 5 events, right, in total. Then again, we kind of do the same thing, right, so we just output the people who won, right, overall. So I think then we can just, yeah, okay, right, so because then we've, yeah, okay, so we've input that into points. So points is storing the total points for each competitor, right, therefore we need to loop through this and see, basically, well, which people scored the highest points, right, from this points array. So let's kind of do that. We want to go for, and again, let's just go competitor index. That can start at 1. We go to the number of competitors. And I think let's also just reinitialize this high score just to 0. Right, so what we want to say is if the points right at the competitor index is greater than the highest score, well then we just want to do what we've done before, so highest score, and that's going to become equal, right, to points competitor index. Yeah, I think that should be fine. So let's go next competitor index. Right, so yeah, okay, that should get the sort of winning points tally, right? And I think then we can just do what we've kind of done here as well. So I'm just going to copy this. Right, let's go event. Yeah, I know. Let's go like overall winners. Right, so overall winners, and I guess yes. So actually, okay, right. Then we just want to do what we've done here again, really. Right, so again, we're just going to loop through all of the competitors, and this time we want to check that what if the points for that person is equal to the highest score. Well, then we just want to output that. Yeah, so let's just go output, and let's go what competitor name. Right, that's going to be at the competitor index, and again, let's go scored. Right, and then yeah, I guess we can just have the points there. Yeah, I think that's all we need to do. Let's just go through and just read this again. Right, so 1D array competitor name contains, right, 25 competitors, yeah. Right, 2D array competitor score, right, yeah, we use that. Yeah, I mean, right, okay, so I think we've done everything, right? So write a program, right, take as input, I mean, yeah, we've done that. Calculate the highest points for each event, yeah, we did that. Right, output the event winners, yeah, output the highest score. Yeah, okay, so I'm pretty sure we've done everything. Right, let's try and test it then, and let's just see if it works. Right, okay, so score for, well, Confucius event 1. Right, so okay, I'm going to make sure that 2 of them get the same, so let's go 60. Right, no value has been assigned to points. Okay, right, so this is, you know, well, yeah, okay. Right, this is something we might have to do. I mean, in reality, as I said, like, okay, yeah, so this is just a new feature of the site. If I turn that off, then I guess hopefully we won't get that error message. Right, let's go 60. Right, okay, then I guess enter score for Albert Einstein. I don't know, let's go 60 again. And Bill Gates, well, let's go 50. Yeah, okay, right, so here then event 1 winners, right, Confucius got 60, and again Einstein also got 60. Right, let's go event 2. Right, okay, let's go maybe 40. Let's go 50, and let's go 60. Alright, so yeah, okay, I'm trying to work out like who's going to win overall, or yeah, okay, let's try and get like multiple winners. Right, so I guess if we try and get 150, so we said, right, Confucius has got 60, and yeah, 60 and 40. So if, for example, here we go 50, right, Einstein. So Einstein has got 60, and then here he's got, okay, right, here he's also got 60. So let's give Einstein just 30. And then, I don't know, Bill Gates, let's just give him 10. Right, so, okay, hopefully now we should have 2 winners. Right, that's going to be what, Confucius and Einstein. So yeah, overall winners, okay, Confucius got 150. Alright, so did I calculate that wrong for Einstein? Probably. Right, so Einstein, okay, right, so Einstein got 60 here. Right, oh, okay, yeah, so then he got 50, right, it was actually Bill Gates who got 60. Right, let's just try and do that again. Let's go, I don't know, like 10, 20, I don't know, let's go 20, right, okay, let's go, 10, 20, 20. And then yeah, 10, 20, 20. Alright, okay, so in this case it should say Einstein and Bill Gates. Yeah, so event 3, and yeah, overall winners, yeah, Einstein scored 60 and Bill Gates scored 60. Alright, so I think this is working. Now, of course, remember, when you write this, you also have to write the comments. So let's just go ahead and do this quickly. Right here, let's say, I know, yeah, loop over all events. I know, yeah, to get input scores. Right, for each event. Yeah, I guess what, and I know, yeah, and output, yeah, winners. Right, winners for each event. Right, so here, right, and yeah, okay, yeah, so I guess maybe we can just say what this is doing. Let's, I know, yeah, reinitialize the high score to be 0, right, for each, yeah, I know, for each event or for each new event. Right, so here, let's say, I know, yeah, loop through all competitors, right, and get their scores. Or, okay, right, hang on, so I guess really we're doing more, right? So loop through all competitors, right, get their scores, right, and add it to their overall points. Yeah, that should be fine. Right, let's say validate. So validate points is right in range 0 to 100 inclusive. Right, so this one, right, we're assigning the points they scored, and I guess we're then kind of updating their total points. Right, let's say I don't know, yeah, assign score to I don't know, yeah, current competitor, and event. Right, let's say also yeah, I know, yeah, also I guess we'll add to competitors total point score. Yeah, that should be fine. Right, so here we're checking if the current competitor's score is greater than the current high score. So let's say, I don't know, yeah, right, okay, yeah, let's say update. Let's say update high score if current competitor, I don't know, yeah, beat that high score or something. Yeah, that should be fine. Right, let's go, I don't know, yeah, output winners. Right, output winners for, I don't know, yeah, let's say, right, this current event. Yeah, okay, let's say, well, loop through all competitors. Right, let's say check if competitor, I don't know, yes, scored right equal to winning points. Right, equal to winning points, and get output. Let's say output them as a winner. Alright, if they did. Yeah, I think that should be fine. And then I guess yeah, okay. So here is basically just the same, right? Yeah, okay. Well, let's say I know, yeah, reinitialize. Right, high score to 0. Right, and okay, this is what for overall. Yeah, overall points winner for all events. Yeah, I think that's fine. Right, so here what we're doing, we're loop through all competitors. Right, and I guess get the highest score. Yeah, I could get the highest score. I don't know, yeah, of anyone or something. Right, and then here, so what we're looping through and outputting all the winners. Loop through competitors and output all winners. Yeah, alright, yeah, okay, yeah, alright, that should be fine. And then I guess here we can just go more detail. Right, let's say check, right, if current competitor, alright, is a winner, right, i.e., I know, scoring equal to the highest score. Yeah, and then I think that's everything. Alright guys, so as always then, hopefully this video is useful. Any questions, just ask in the comments, and I'll see you again in the next video.